So before the break, I know it seems like so long ago. I wasn't here Friday. Before the break, you had a sub, and the sub gave out this worksheet, and I offered it to you the day before if you thought you might be absent. This will be part of a homework check, not tomorrow's, okay? But I'm telling you ahead of time that I am going to have it be part of a homework check at some point, not tomorrow. So if you didn't get one, let me know, and I will bring you one. Anybody know for sure they didn't get one? This is what we worked on the day before the break, the trig review. The key is on Canvas. If you need to check it. Anybody else need that? Okay, so while you're writing this, we're going to do 3 examples in the notes, and you have 6 homework problems. Tomorrow is a work day and a homework check day. Tomorrow is a work day, no new notes, no review assignment. Today's assignment is kind of like the review assignment, okay? And guys, 3.12 is our hardest section of the year. It is. It is the hardest section. This is why I'm letting you have an open note quiz. So I'm going to be encouraging you as we go through this and tomorrow, making sure all your notes are in one place, all your homeworks are done. I mean, we have a homework check anyway, so you'd want that to be the case. Any questions you have, you want to ask, because when you come on Wednesday, you can use your unit circle, you can use your formula sheet, you can use any of your notes, any of your homework. You just can't use your neighbor's stuff. You can't use the internet, okay? You have to have it in your binder. If it's in your binder, you can use it, okay? So that's Wednesday. So if you're not here tomorrow, take some time to make sure that you have all of your stuff, up to date, that you know where all your notes are, that you have your unit circle. If your teacher's letting you use the unit circle and I've been telling you you have to memorize it all year, why wouldn't you? So, and I'll encourage you guys about a couple different things as we go through this. And then tomorrow I'll give you some ideas of ways to review for the quiz if you feel like you need to. If you've got everything done and you want to review, I have some really good ways of you doing that, right? But just be ready for the quiz on Wednesday by having everything completed is the moral of the story. So we have this quiz on Wednesday, and then we have 3 sections left after this. That's it. And then we're done with all the new material in the course. Those 3 sections are something called polar equations. It's something you've never seen before. Not difficult, but it's brand new. And that's, we'll have a project that I give you guys during that. That's the pictures things over there, which counts as another quiz grade. But anyway, we'll get to that. But we're almost done, all right? Almost done. Yeah? You mean the AP exam? Yes. Yeah. So, sorry if I didn't make that clear. So we have those 3 sections left, 313 through 315. Those are the last 3 sections of the course. We'll have a test after those 3. So nope, just those 3 sections. Then we have a mock exam. That is your second test. A mock exam is everybody gets 100% on. So it's really this, for the most part, guys, this quiz is going to be the hardest part of your 9 weeks. This is hard stuff, okay? So trust me, I'm not trying to trick you on this quiz. I didn't teach you a bunch of stuff, do a bunch of examples with you, and then make a quiz up that has weird stuff on it. If it's on the quiz, it's something we've done. So if you have all your stuff, you should be able to find it in your notes, okay? All right, so what we're doing here, I didn't write out the whole directions, but by looking back and seeing your work, you'll know what it is. What this would normally say is find the exact value of cosine of 17 pi over 12 by using a sum or difference formula, okay? And what this is saying is we had quiz after quiz after quiz of the trig identities, not the trig identities, the exact values. This is stuff we had to memorize, remember? This is the same question, but you wouldn't have seen cosine of 17 pi over 12 on here because it's not on the unit circle. It's not one of our standard angles. So we have to have other ways of finding angle measures and trig functions of different angle measures that aren't like our standard angles. So someone invented the sum and difference formulas and the double angle formulas, and that helps us use angles we know something about to find stuff that we don't know about, okay? So what we want to do is find two angles on the unit circle that add up to 17 pi over 12. Well, we've done this a whole bunch of times where it was like 5 pi over 12, 7 pi over 12. This is a review. And the first thing we did was take our quadrant 1 angles. Why quadrant 1? Because quadrant 1 is the easiest quadrant. And change them to denominators of 12. Now, we've done this several times in our notes, several times in homework problems, so you probably have this written somewhere else, but as a reminder, you would multiply this by 2, so we multiply the numerator by 2, multiply this by 3, 3, multiply this by 4, 4, and when this was a 5 or a 7, it was easy to come up with two angles that add up to 17, or subtract. It can be add or subtract, it doesn't matter. So, but if you look here, none of my numerators are big enough to get 17. So this is an example which we haven't seen before, where you have to go into quadrant 2, okay, or 3, or 4. You decide where you want to go. It doesn't matter. But let's go into quadrant 2. So same 3 denominators, trying to squeeze them here. In quadrant 2, I'm subtracting 1 from each of my numerators. And I'm going to change these to denominators of 12. And we're hoping we can find something that adds up to 17. So times 2, times 2, times 3, and times 4. Sorry. So that's 10 pi over 12, 9 pi over 12, 8 pi over 12. And hopefully you see that these two, if I add these two together, 9 and 8, I get 17. So that means I'm going to use the cosine sum formula of 3 pi over 4 and 2 pi over 3. And it's open note quiz. It's on your formula sheet if you've updated it. And in a minute we'll be using the double angle formulas. But you can also go to page 145 in your notes if you want to write that down somewhere, because maybe you don't like your handwriting on your formula sheet, like I don't like mine. But page 145 is where we learn the sum and difference formulas and the double angle formulas, which we'll talk about more in a second. So again, I think have these memorized, these especially, but you don't have to have them memorized for this quiz, okay? So I'm going to use the cosine of these two added together, okay? So it doesn't matter which one you put first, it's addition. The order of adding two numbers together does not change the sum, so I just put them in this order. And if you remember that we call this guy alpha, this guy beta, right? And you can use the formula sheet or your memory to expand this. Remy, do you ride a bus? Okay, I'll give this to you. It's just a bus route change or something. Okay, so using my formula sheet or my memory, I remember cosine is the non-social one. He likes to only hang out with other cosines. And C, change, plus to minus. Okay, remember alpha, beta, alpha, beta, alpha, beta, always in that order. And I can use my unit circle or my brain, whichever one, to remember what cosine and sine are of these two angles. So any of my denominators of 4 are square root of 2 over 2, square root of 2 over 2, and in quadrant 2, cosine is negative. And 2 pi over 3 would be 1/2 square root of 3 over 2, with cosine being negative. And don't forget what you already know, guys. Cosine, sine, right? Cosine comes first, then sine. So I'm just going to now substitute, if you will, those values in for these. So cosine of 3 pi over 4 is negative square root of 2 over 2 times cosine of 2 pi over 3 would be negative 1/2 minus sine of 3 pi over 4 would be square root of 2 over 2, and sine of 2 pi over 3 would be the square root of 3 over 2. And now we can put it all together and get our final answer. So negative times the negative is positive, and don't forget when you multiply, you don't need a common denominator. The confusion I always see is that students see a common denominator, say they think it's going to be a 2 there, and I see it on this quiz. Every year I give this quiz as open note, and it drives me crazy because there's so many of these examples in our notes and homework, and never did I leave it as a 2, okay? So just use your notes. Square root of 2 times the square root of 3 is the square root of 6, and 2 times 2 is 4. And you can write that a bunch of different ways. We've talked about that. One thing to note, if you had put 2 pi over 3 first, which is totally fine, remember the order of these two could be flipped, it would have just put this guy in front of this guy. They mean the same thing, right? The square root of 6 is negative in both cases, and the square root of 2 is positive. So any of the ways that I've shown you you can write your answer is totally fine. You don't have to show all the ways, write one of the ways that this answer could be written. Okay? All right. For the last 2 examples we're going to do, we're solving an equation. We're solving an equation. And we've solved equations before with trig. If you go back into section 310, that's where I first introduced solving equations to you. This is no different. When we solved equations in 3.10, we used different identities to solve. So you would look for something in the problem that was a reciprocal function. Remember, like if you'd see cosecant, sometimes you change it to 1 over sine, or you change tan to sine over cosine. We had all different ways of solving. But now, you'll be, in this section, you'll be replacing something in the problem with a sum or difference formula, or a double angle formula, something like that. So the first thing, this is how you would start any of these problems, is say, there's got to be something I can quote-unquote fix in the problem. Look for something that's on your formula sheet, or page 145. And what you should notice is that there's a double angle for sine. Double angle for sine or cosine means there's a 2 in front of the variable, whatever that variable is, okay? That you should recognize as one of your double angle formulas. Remember, they used u here, but you can use x or theta or any letter. And sine of 2x or whatever, you can replace with that. Remember, that's what identities are. They're facts. I can substitute one side for the other. And that's what I'm going to do. I'm going to substitute sine 2x for 2 sine x cosine x. I just got that right off that formula sheet. Plus cosine x equals 0. And what I hope you guys notice here is that you have a GCF. This is a binomial, and they both have a cosine x in common. Because one problem that you should notice here is when you have addition or subtraction of different trig functions, you're mixing sine and cosine together. You can't solve it the way it is. So you may think, well, we didn't solve that problem by going from sine and cosine. We still have sine and cosine mixed together. But the way it's written now, I can factor out a GCF. I can factor out cosine x. So I'm dividing this guy by cosine x and this guy by cosine x, and whatever's left over goes into parentheses. So cosine x's cancel. I have 2 sine x plus what? What's this going to be? 1. And you might still be thinking, well, that didn't solve the problem, but I still have sine and cosine mixed in the same problem. But we did solve that issue because now they are factors. They're not added together, they are multiplied. Once we get to where we're factored form, you can just take each of them separately and set them equal to 0 and solve them as 2 separate equations. So this is cosine x equals 0 and 2 sine x plus 1 equals 0. And this step here you could have skipped if you felt so inclined, because I have to still solve for sine x by subtracting 1, dividing by 2. So I don't have to see that work. Okay, this one was already the trig function and a variable by itself. And now it's unit circle. Now I know you guys, and I'm not judging you, I won't judge you on quiz day. Why wouldn't you have your unit circle out to make sure you're right? But I am still teaching you as if you don't have the unit circle, because remember, you have to know it, okay? So where is cosine 0? That screamed quadrantals to me. So, you know I love to draw this. It helps me so much to really see it. So cosine is 0 up at the top and at the bottom. So for this part of our equation, we would get pi over 2 and 3 pi over 2. And then what denominator is sine 1/2? They remember? 6, good. And sine is, let's just take calculus, sine is negative in these two quadrants. So in quadrant 3, I add 1 to my denominator, and in quadrant 4 at 5, I go to 7, 11. So these four, all four of these in any order are your solutions to this equation. Yes? What's that? How I got 6 as the denominator? Because my denominators of 6 have a sine of 1/2. You got good scores on the trig quizzes, Rennie. Are you back? Does that ring a bell now? Guys, don't forget that your ordered pairs are cosine sine. It's alphabetical order, right? CS. So where is the y value negative 1/2? That's my denominators of 6, and so that's what I did. But you can use your unit protocol on those ones. All right, last example is example 16. No other questions here? No? Okay. I like it when you guys ask questions. Okay, so last one, solve this equation. I can tell you this one has a little bit of work involved. Number 2 and number 4 in your homework today are just like this. And there's definitely one of these on your quiz. So you definitely want to know how to do this. So remember, two things we're looking at here. First thing is we've got addition and subtraction with 2 different trig functions, cosine and sine. Okay, that's a problem. So then you say, okay, to be able to solve this, there's got to be something I can fix. There's got to be something on my formula sheet or page 145 that I can replace. And I'm hoping you guys are recognizing this is double angle formula for cosine, okay? Now, cosine's more complicated-ish. It has 3 options, 3 of them. And there's different times when different ones can be used. And it's very easy to know which one to use. I'll tell you that in a second. When I taught you double angle formulas and we did problems with double angle, I said, remember, like on this problem, I said you could use any of them that you wanted to. I liked the first one the best because it made you have a common denominator. But when we do this example right here, when we do this problem, we don't want the cosine and sine mixed together because that doesn't solve our problem. Remember, we're trying to have everything be the same, okay? And this has got a subtraction sign between it, so it doesn't solve the problem. So I have to use one of these 2. How do I know which one to use? Well, since there's sine already in the problem, I'm going to change this to the one that has just sine in it. So I'm going to replace cosine 2x with 1 minus 2 sine squared x. That's how I know, okay? So I'm going to change that to 1 minus 2 sine squared x. That's all I did. I just replaced that with that. Again, how did I know to use that one? Because now I have my entire equation is the same trig function, in this case sine. If this had said 3 cosine x, which is the one, number 2 and number 4 have that in it in your homework. If this had been a cosine in the given problem, well, I would have used this one because that would have meant everything was cosine. That's how you know which one to use, okay? Now, what you should notice is there's a quadratic in this problem. There's a squared. In algebra, whenever we have a x squared and an x and a constant, it's this form, right? So I want to put this equation in this form. So what you should notice, first of all, is that we have 2 like terms on the same side. That's your constant. Those are your variables, your numbers that have no variables. So 1 minus 2 is negative 1. So I would have negative 2 sine squared x, that's this, plus 3 sine x, right? So I just brought those straight on down. And then 1 minus 2 is negative 1. So like negative 1 is my C value. See that? And to be able to factor this, which is what I'm going to have to do, A should be positive. A right now is negative. So the rules of algebra apply in this, where it says you can do anything you want to an equation as long as you do it to both sides. What do I want to do? Multiply everything by -1 would solve the problem. Okay, that would make this positive. And so in case you, like I normally wouldn't write this step, but if it helps you when you go back and look, that I'm multiplying everything by -1, that way I can see it in my notes, but I don't have to see that step. It just changes everybody's sign. 0 stays 0. Okay, so that's a nice, easy algebraic way to get it in the right form, because to factor, your A value should be positive. And this is a chart problem. This is a chart problem. And you might remember when we factored these before, what I said made it easier to do was, and this is optional, you don't have to do this. You could leave the word sign in all your problems, but it does make it a little bit friendlier to take the word sign out and factor it like you would in algebra, and then later step, slip the word sign back in. It just looks easier. But again, optional, you don't have to do that. So I'm looking at this and I'm saying what two numbers multiply to get 2 and add to get -3. Well, there's only two numbers that multiply to get 2. So it's got to be these two numbers. And then we want to make it a -3. So these would both be negative. Let's make sure it works over here. It does. Because of the 2 in front of the x squared, we have to bring down the outside 2, split the middle. So bring this guy down, split this. Doesn't matter which one you put first. Doesn't matter. Make sure you give them both a variable. And bring down the +1. What's the next step? Yep, the grouping. Parentheses, parentheses. I mean, how many times have we had to factor in this class? I told you day 2 or 3, you have to be good at factoring in this class because it doesn't go away. You should be annoyed by it, because I am. I get annoyed by having to do it, but it shouldn't be hard at this point. Don't forget, whenever the first term in a set of parentheses is negative, you factor out a negative. And you have to put a number here, guys. What's the number that all numbers have in common as a factor? 1. So if you have to put a 1 there, you have to put a 1 there. Remember, your parentheses should be identical twins. This is where I would choose to put back in the word sign. Anywhere, so x minus 1 is one of my factors, right? X minus 1. So I'm just going to slip the word sign in front of the x. Sign x minus 1 equals 0. And you could have skipped that step and gone right to the next step, which is this. Right? You've got to get sign x by itself. Add 1 to the other side. And then the other one, 2 sine x minus 1. Sorry, squeezing there. And again, could have skipped that step and just added 1. Divide by 2. And then back to the unit circle. Where is sine 1? Up at the top, right? Sine is 1, up at pi over 2. And sine is 1/2. Remy, what denominator? It's okay. It's the same as before. 6. Yeah, remember, square root of 3 over 2 comes first. And sine is positive in quadrant 1 and quadrant 2. So those 3 are your solution. So there's a lot going on in that problem. There's a lot. There's a lot going on in all these problems. There's a lot you have to remember and look for. Hopefully you go through my steps, you use your notes really well. Okay. Question on that one before we go to the homework? Yes. Like here? Is that what you're asking me? Pick one? Is that what you said? Yeah, but sine is positive 1/2 at pi over 6 and at 5 pi over 6. Okay, so anywhere that occurs. When do we only get one answer? At the quadrantals sometimes. That's why we only had 1 there, because sine is 1 Here, it's -1 at the bottom. So that's, sometimes you might only get one answer of the quadrantals. Okay, yeah, sure. All right, so here is the homework. You're changing number 5 and 6 right now. Everybody should be writing it because then I'm going to do number 1 with you guys. So fix number 5 and number 6. There's a reason why I changed these problems. I didn't do a very good job here. Give me one second. There's the assignment. Fix 5 and 6, and then I'm going to do number 1 with you. These are going back to the beginning of 3.12, like day 1, day 2, because those questions are on the quiz too. So remember I told you that today's assignment is kind of like your review assignment. I'm not giving you anything new tomorrow. You would want to make sure you know how to do everything on this page for sure, and then go back and fill in any blanks on other assignments. Yes. Uh-huh. All right. So I'm going to do number 1 with you, get you going. Okay, I'm going to put the key up in a second. So if you didn't finish writing it, you'll be able to write it down. Okay, let's go to number 1 and work on this. Guys, first thing you should notice is that we don't have a 0 on the right-hand side. So one of the things we're going to do is move the 2 sine x over. Then I'm going to combine that with another step. And that is, there should be something I have to fix. And you should notice there's a double angle for sine right here. Okay, so that is 2 cosine x, sine x. It doesn't matter if you put sine first or cosine first, it's all multiplication. And I'm also going to bring the -2 sine x over, because you want to have a 0 on one side. And this, I hope, screams and yells in your face that I'm a GCF problem. There's no squared, so it's not quadratic, it's not factoring, like that kind of factoring. It's just factoring out a GCF. We have a sine x in common. Oh, actually a 2 sine x. They have a 2 in common too. 2 sine x. Hold up real quick. It's not like watching. And yes, it's a problem in the purple step that sine and cosine are all mixed together. But now that we've factored it, it's okay that sine and cosine are mixed together. Because now that they are factors multiplied together, that's what that means, we can set them equal to 0 separately. So you could skip this step in green if you could go ahead and do this on your own. You know I like to show a lot of work when I'm teaching. But I would divide both sides by 2. 0 divided by 2 is 0. Add 1. And now unit circle, sine of 0. Sine of 0. Sine is 0 here and here. 2 places. Here and here, right? Sine is 0 in 2 places. That is at 0 and at pi. And cosine is 1 also at 0. So you get 0, you get 0 over here. You only write it once though. You got a duplicate answer. You only have to write it once. So 0 and pi are our 2 answers. Okay. So looking ahead, remember I told you 2 and 4 are the factoring ones. Notice in both of those problems, 0 is already by itself. In both problems, you've got a double angle formula for cosine. And in both of those, you have also cosine in the rest of the problem, okay? You have to fix the double angle formula to one of the doubles, one of these. And since cosine is already in the problem, you would use the one I have circled in pink, okay? And I'll put the key up, but I just want to kind of talk to you about that. Please don't just copy the answers. Ask me for help. Work together. I don't mind you working together. I'm going to zoom in a little bit for a minute, and then I'll move it up a little bit. So I want you guys to be able to see number 2 a little better. Yeah. Please, please, please ask me for help.
What can you do with the one where it shows like it looks like, I don't know,
145, like all the different,
you don't pass it.
the sum and difference formulas. Yeah, page 145. See if that's what you're
Yeah.
passing. Like dog ear it, so you know where to find it, during the quiz. It's also on your formula sheet, like all of them are on your formula sheet, if that helps you too.